In this video, we are going to work on multiplying polynomials. If you remember, we have polynomials are basically just terms with variables and coefficients, such as we see down here. This part, 3x squared, would be considered a monomial. Same with 4x, that is a monomial because it is only one term. Here, inside the parentheses, we have a polynomial, or you could also call it a trinomial, because it is made up of 1, 2, 3 separate terms. So a trinomial has 3 terms, and polynomial is just the fancy word for many terms or many numbers. So in this video, we're going to focus on multiplying polynomials together. And it's not too terribly hard. The main thing we want to make sure we do if we are multiplying monomial times monomial, as we see over here on the left, is to first multiply your whole numbers, or your coefficients. So I have 3 times 4, which is 12. Then I need to multiply like variables, so I multiply x squared times x. And if we're not too good at remembering how to multiply variables, think of it this way. X squared, I'm going to do it up at the top here, x squared is x times x. And we're multiplying this by another x. Well, what is x times x times x? You're right, that is x to the third power. So here I have x squared times x, and our answer becomes x to the third. So 12x cubed is the product of 3x squared times 4x. And this can be done with any monomial times any monomial. Let me erase this and let's try a different set of monomials. Let's say I have 5x to the third y, and I'm multiplying it by 6x squared y to the fourth. This is a little more complicated. We see 5 and 6 as our numbers. Both terms have x's, and both terms have y's. But it still follows the same idea. First, we'll multiply our numbers, our coefficients, together. 5 times 6 gives me 30. Then, we multiply variables by the same variable. So I multiply x cubed by x squared. That gives us x to the 5th power. Because remember, the shortcut for multiplying variables with exponents is to add their exponents. So 3 plus 2 gives me 5. And then lastly, we multiply our y with our y. Well, y on its own is a y to the first, and then we have y to the fourth. So just like with our x's, we add the exponents, and 1 plus 4 gives us an exponent of 5. So 5x cubed y times 6x squared y to the fourth is 30x to the fifth y to the fifth. And there we have it, a couple examples of multiplying monomials by monomials. But what if we have a monomial times a polynomial, as we see here? I'm going to erase some of this stuff over here, and let's take a closer look at this monomial times a polynomial. Alright, so here is our monomial of 7x times our polynomial of 2x squared plus 3x minus 4. In order to take care of this multiplication, we have to use the distributive property. And the way I like to do this is by showing little arches for our multiplication. Because in order to multiply 7x by all of this, 7x has to multiply by each individual term, which I'm going to underline here. So one term is 2x squared, another term is 3x, and the last term is a minus 4. And this 7x needs to multiply each term. So we break it up into 3 separate pieces, and we work on it that way. So first I have 7x times 2x squared. I'm just going to pretend that this stuff over here is not a part of the problem. I'll come back to it later. So, like we saw with our monomials, first I multiply the coefficients. 7 times 2. That gives me 14. Then I have x times x squared. Don't forget that this single x has an exponent of 1. So I have x to the first times x squared, and I'm going to add these exponents. 1 plus 2 gives me 3. So I have 14x cubed just for my first term, from multiplying these pieces together. When we did our monomial times monomial, we were done at this point. But I still have other terms here. I've got to multiply by 3x, and then I've got to multiply by negative 4. So now I'm going to move on to the next piece, and I'm going to forget that the first and the last piece are there. So I have 7 times a positive 3, which is a positive 21. So I add 21 to my expression, and then I have x to the first times another x to the first. This x times this x. And x times x gives me x squared. Now I've finished multiplying my second term in my polynomial. And lastly, I need to move on to my final term. I need to multiply 7 times a negative 4. That gives me a negative 28. And even though this variable, or this number does not have a variable after it, this x still tags along. So I do the 7 times the negative 4 to get negative 28, and I don't lose any variables. So I have just a single x after 28. And this is my product. 14x cubed plus 21x squared minus 28x. This process might take a little getting used to. It's sort of odd that we have to multiply each piece individually, but if you watch part 2 of my video, I'll show why that needs to happen, and we'll also see what happens if I have a polynomial times a polynomial. But let's try one more of a monomial times a polynomial, just to make sure we get this process down. So let's pause the video and get set up for the last one. For this last example I've created, it's kind of a doozy. I have my monomial as 5r squared s cubed, and my polynomial is 3r squared minus 2s squared plus 4r cubed s to the fourth. Even though it looks a lot more challenging, this is the same exact process as the last example. We're going to take this monomial on the outside, and it is going to get multiplied by every single term on the inside. So we'll first start by drawing our arches. I've got 5r squared s cubed times 3r squared first. After we're done with that multiplication, we're going to have 5r squared s cubed times negative 2s squared. And then lastly, we'll have 5r squared s cubed times 4r cubed s to the fourth. So let's get started with our first two terms, 5r squared s cubed times 3r squared. We're going to start by multiplying the numbers, the coefficients, and 5 times 3 gives me 15. Now look at the r's. I'm going to multiply r squared times r squared. We're going to add these exponents. 2 plus 2 gives me 4. So I have r to the fourth. Now I have an s cubed here, and I don't have an s cubed or an s term at all on the 3r squared. So that means s cubed is just going to tag along as itself. It's not going to change. So my first term, yeah, that's a bad s, is going to be 15r to the 4th s cubed. This did not get changed because there was not an s to multiply by over here. It also didn't disappear. Alright, next we've got our outside monomial again, times negative 2s squared. We have to treat it as a negative 2 because of that subtraction sign. So 5 times negative 2 is a negative 10. So we'll put in a minus 10 to our expression. Now I like to keep my variables alphabetical. R comes before s, so I have r squared here, and I don't have an r term here. So just like with the s cubed in the first multiplication, that r squared is going to tag along and it's not going to change at all. I've got minus 10r squared, and now I look at the s's. I have s cubed times s squared. 3 plus 2 gives me 5, so I end up with s to the 5th. And my second term in this polynomial we're creating is negative 10r squared s to the 5th. Alright. If you're getting the hang of this, why don't you try pausing the video and see if you can finish off this last term all by yourself. If not, we'll go over it in a second. So, pause the video and give it a shot. Alright, for our last term, we're going to start off with multiplying 5 times 4, which is going to give me a positive 20. Now I have an r squared outside, I have an r cubed inside, so we'll add those exponents. 2 plus 3 gives me 5. So 20r to the 5th. And then lastly, I have s cubed times s to the 4th. Now this is the first time in this problem where both variables are present in both numbers. So I'm going to once again add my exponents. 3 plus 4 is 7. And I end up with s to the 7th. And this is our product. 15r to the 4th s cubed minus 10r squared s to the 5th plus 20r to the 5th s to the 7th. In our second video, or in part 2 I should say, we're going to see how do we handle it when we have something like this. 5x plus 2 times 3x plus 1. We're both going to have polynomials multiplying each other. But that's part 2, so if you've enjoyed this first part or you need help with polynomial times polynomial, make sure to check back with part 2. And good luck!